Today, we're going to talk about something that I've been personally introduced to over the past, I'd say, 2 months. And Payload is a software package that Elliot and I are working on as a startup. But we are currently evaluating new ORMs for different database support right now. Right now, we're only MongoDB, so we're adding a bunch of relational databases. And with that comes a change of ORM. And there's a lot of different ways that you can generate TypeScript interfaces that are based off of your database schema. Two of the two are generated versus inferred. And generated is like you run a step in your code and it generates a file that has all of your TypeScript interfaces. And then inferred is where your IDE can automatically just infer the types based on what you've already declared, and you get real-time updates. And there's very interesting pros and cons to each of the approaches to that. And for the last 2 months or so, I've been beating up the different approaches quite deeply. So I'm going to talk through that today. The real thing, like in TypeScript or any kind of web application specifically, is like, where's your source of truth for your like TypeScript interfaces or any type of shared code? Like, there's a lot of places where you might have your data shape reflected. You could have it in manually written interfaces yourself that you maintain. Your GraphQL schema is probably going to have that layer of type safety in it. Your schema validation, if it's Zod or if it's Joy or whatever you're using, all of these things reflect the shape of your data. And like, where's the source of truth for that? Like, if any of you have ever built like a large web app from scratch, you're like, I feel like I'm repeating myself a lot. Like, I have to write the validation, and then that might generate a TypeScript interface, but then I have to write my ORM schema, and then my database also maintains its own shape. Like, where's the source of truth there? It's crazy, and it kind of makes me want to jump out of a window. I wish there was a better way to like simplify and keep everything in one place. But so I'm James, I'm the CEO of Payload, and Payload is a content management system and an application framework, kind of both. I'm kind of a mutt. I am a designer and a full stack engineer. I didn't go to school for this, I taught myself, but I've been mostly in the JavaScript world. I did a little bit of PHP back in the day, but for the last, I'd say 10 years or so, it's been mostly JavaScript. And then Elliot got me into TypeScript. So for the last, I'd say 3 years, I've been in the TypeScript world. And man, I'm really happy that we rewrote Payload in TypeScript. That was a huge thing. We started Payload in JavaScript, and I thought it was fine. I didn't know any better. And Elliot was like, nope, we need to do this in TypeScript. And I fought him. It was a battle for a minute, and he won, and I'm really happy that he won. It's really like we've refactored deeply since then, and I can't even imagine doing that without TypeScript. It's just like, it's such a white and black decision for me. But Payload kind of sits in between app frameworks and content management. And on the app framework side, you can build whatever you want. If you're going to build a new product, you're probably going to start with an app framework. It's got great developer experience. It's got what you need as an engineer, but the admin UI sucks. You probably have to find a third-party package that wraps around whatever you're building. So if it's Django or Laravel or Rails or whatever, there's these CRUD UI packages that you can pull down and use, but they're not meant for non-technical users, and they always have massive shortcomings. And if you need to do something like maintain versions or build in complex access control and show and hide fields based on different combinations of other fields' values, like that side of things falls apart very quickly. So you always have to kind of build your own UI for your app framework. But then Payload, and on the content management side, on the other side, that's where admin UI actually shines. It gives you what you need out of the box. And generally, non-technical people will actually be able to log in, and they're not dealing with PHP MyAdmin. They're dealing with like something that's made for them. But the problem is that devs hate CMSs, me included. If any of you have ever worked with WordPress, you probably wanted to pull your hair out afterwards. It's not fun. They're not built for engineers. The DX is terrible. And generally, you really only build websites with CMSs. But with Payload, we kind of split that gap, and you can build full apps with Payload. It gives you the automatic interface. It gives you everything you need. It's got very strong type safety built in, and it's kind of in the middle there. So we went through Y Combinator last year. Our lead investor is Gradient AI, which is a Google firm, and MongoDB Ventures also invested in us, along with a handful of other VC firms. So we were about 1 year in, and it's been crazy. I thought my life would get easier moving from an agency to a product, but it actually got a lot more complex. So I like it though. It's been fun. But anyway, I'm not going to shell too hard up here. If you're working with an ORM, generally, we're talking about the source of truth, and it's probably going to be your schema, like how you declare your schema in the ORM. That's like the most true form of your source of truth. So if you're going to look at like trying to leverage that shape in TypeScript, it makes sense that that's going to come from your schema itself. And a lot of modern ORMs provide interfaces for you. So you define the schema in whatever ORM you're using. Here's a couple. Drizzle is, we actually are building our relational database support on top of Drizzle. Who's heard of Drizzle before? Got a couple? Two? Well, they're new, so you might hear about it more in the future. Who's heard of Prisma before? Okay, a couple more. Prisma is way bigger than Drizzle, but Drizzle, it's a group of very talented engineers, and we've actually sponsored them because we're going to rely on their technology quite a bit. Certain ORMs generate interfaces for you, but then back in the day, you would have to find some third-party library to take your schema and then translate it into TypeScript interface generation. So like Mongoose, for example, has no TypeScript support at all. Like you have to manually write your interfaces, or you have to pull some third-party package. But they're all still trying to figure out how to do it. Like no ORM really has good type generation nailed. And I mentioned the two different approaches, generating interfaces with like a generation step, but then full inference, like that's just completely dynamic, no generation at all. And the funny thing about software engineering, I don't know who wrote this. I looked it up, tried to find a citation, but like 30 people claimed credit for this quote. But like you got to compromise in the engineering world. Doesn't matter what you're doing. If it's choosing a front-end library or if it's choosing a database, are you going to go with NoSQL or SQL, whatever, there are always trade-offs. And there's some really interesting trade-offs with these different ways to generate TypeScript interfaces. Number one, inference. At first pass, it seems like this is going to be a really good way to do things. And I have a little demo pulled up in Drizzle, actually. So here's just a really, really quick Drizzle schema declaration on the right-hand side. This is a SQLite table, and it's called people. And I have 4 columns, really simple stuff. And on the right-hand side, this is just me writing a quick node script to demonstrate some of the inference. And if I, let's say I put title to non-null, and then I removed it here, it's instantly going to yell at me because I don't have that defined in the schema, right? So those changes take effect immediately. If I removed not null, then the error will go away just immediately. Inference is really powerful for that. But it does have some drawbacks. The first thing, that what I just showed you is huge for DX. Like when we were doing a proof of concept for how to map our very nested data structures from MongoDB over to a relational world, we did a proof of concept just in a standalone repo, and we just iterated very quickly, and the DX that comes with type inference is just massive. You can't say that enough. You can instantly see your errors. You don't have extra lines of code, like a generated file that could be 500 lines long. You don't have to deal with that. It feels like the future. I really like it. There's no additional step. You don't have to have a node server running and generating on file changes or something like that. It just does it for you. But it also has some drawbacks. Number one, clicking through, if you've ever pulled off a third-party library and it had really strong type support, and you just click through and you instantly see a very, very clear definition for arguments or the return from a function. That's an invaluable tool as a TypeScript engineer. Just being able to see at a glance, click through, bam, that's what I'm doing. It's one thing to get auto-completion in your IDE, but it's another to go to the definition and actually see it right in front of you. But with inference, oftentimes the patterns behind the scenes to properly infer types are extremely convoluted. And TypeScript generics are pushed to their absolute limit when you infer. Everything is a generic. And if you click through, you're going to see the generic. You're not going to see your type. And then you're going to have to reverse engineer it, and it's just going to get crazy. And reusing your types, well, I'll get to that in a minute. Another thing is a lot of inference can bog down your IDE, and Drizzle actually has a pinned GitHub issue that people are saying, like, this is way too slow for me to use. Like, I don't think anybody's really figured this out yet, like, smoothly. And I don't know that it's ever going to be possible with the way that the TypeScript compiler currently works. Because at a certain point, you're just asking it to do so much. And if you have 10 tables, maybe that's fine. But if you have 100, then it's going to be very, very slow. And it's just like, they might have some ways to fix this, and I hope that they do. But this is a serious drawback right now, is that like too much inference can really slow down your IDE. I hope that that's solved in the future. But another thing is portability. So one thing that's great about generating interfaces from your schema is that you can reuse them in other applications. Like, we're a headless content management system, so there's always some front end somewhere. It could be React Native, it could be a website, it could be Next.js, it could be whatever, but like with Payload, you can reuse your types in your front end applications wherever you want. And that's just end-to-end type safety immediately. Like, you can use them for React props and whatever you want. You can move them all over the place and get that done. But if you're gonna infer from a schema, then guess what? You need to have the ORM installed in your front end as well, just to be able to define your schema and then infer the types. You need to have all those ORM dependencies in your front end, and you need to share your entire schema just to share your types. So there's some difficulties with portability there. And so overall, I mean, it does feel like the future, but I think there's still some interesting challenges to be solved there. The next one is generation. So it feels old school. There's not a lot of black magic here. It's very easy to understand how it works on the back end. And you could get a junior engineer in there to work on a project, and they'd be able to make some quick work. So here's a little demo of type generation. And I think I have to have my server running, yarn dev. So here's Payload. This is what our configs look like. So here's a collection, and we have, it's called people, and there's two fields, first name and last name. And what that translates to is this interface right here. And you can import this interface and use it wherever. We automatically import these for you behind the scenes, so you don't have to import these to work with Payload, but you can use these for anything you want outside of Payload itself. Not only does Payload leverage them internally, but also you can use them in your own code. And it's very clean. As you can see, it's basically exactly what you would expect. But if I add another field, let's say nickname, type text, and I save it, then bam, the generator, you saw that, like the generator is running in the background. It's a node service, but basically what it does is it just generates it as after you save the file. It's not automatic. I had to save to make that work. So there's an interesting trade-off there, but it does produce some very serious benefits as well.
So if I was shipping this to my customers, and I mean, not everybody would do that, I suppose. It's because it's mostly kind of like backend, but I would ship them the payload types.ts file, and they would be able to use, okay.
Yep, and there's obviously a million ways you could do that. If it was like a specific NPM package that had like utilities or like a SDK or something, you could ship it off to that NPM package and have them install that, or bundle it directly with your SDK or whatever you want to do. But yeah, this file is portable, and it's basically, it's in version control. So you can share this wherever you want.
Great, thanks.
Yeah, it's, like I said though, I have to have that node service running in the background, right? And it doesn't automatically show me. Like where Drizzle, when I added this field, let's say I delete this field, this is not gonna change until I save that file. So that's obviously the drawback. Feels a little bit old school. Inference seems a lot better, but let's talk about some pros and cons here. First thing, keep it simple, stupid. Honestly, I'm a big fan of not over-engineering something until you absolutely need to. And that just helps the pace of your production, and it helps everyone on the team be able to be proficient with tasks that might seem complex, but if you can keep them simple, everything is going to be more reasonable to work with. And type generation, what we do inside of Payload is there's a package called JSON Schema to TypeScript. We have to maintain a JSON schema of the config that the authors write. But then this package takes your JSON schema and it translates it to TypeScript interfaces. So it's as simple as can be. Like you just pass in your JSON schema and it comes up with that file for you. And there's really very little black magic that happens there. So that's one huge thing. Like if we ever have a problem with our type generation, we know exactly where to look. We don't have to filter through 1,000 different TypeScript generic functions to like root out the cause of the issue and deal with like our nightmares.
So with JSON Schema to TypeScript, do you ever run into issues where you've defined something in JSON Schema that is not possible to represent in TypeScript?
No, even like references in JSON schemas work beautifully in that package. So like in Payload, you can have like 30 collections and you can have relationships between collections. But as long as you write the JSON schema correctly with the references, even relationships will automatically populate. So you can say like, give me posts with comments. And then the TypeScript type has a relation or it has a union to the different collections that you reference immediately. And that's a pretty complex thing, but it handles it beautifully. Literally everything that we've ever wanted to declare in an interface is possible with that package. But as I kind of showed you, that file, it's very easy to read and click through to. And that's a huge win, just for DX in general. Like, it might seem weird that it has to generate and it might be out of date, but at the same time, if you click through, you literally go straight to that definition that is like self-documenting for you. It's very, very clear. And you can use those generated types as a reference to your schema even. If you wanted to go see like maybe your configs are getting quite large when you're with your schema declaration, but if you wanted to hop over and just take a look at the reference for your schema, all you have to do is pop over and take a look. So has anyone ever used TRPC before? A little bit. That's amazing because it's end-to-end type safety, right? Like that feels also like very much so the future. And the problem with that is you still need to share dependencies and go back and forth, but with these generated types, it becomes very trivial, and it doesn't matter if you're like using your custom endpoints or maybe even like a local node API to access your database directly, you can still leverage these types even outside of something like TRPC. So you don't really need it anymore. And end-to-end type safety is invaluable. It's just a game changer. The problems, obviously they have to be generated frequently, and there is an overhead to that. It takes like a second to generate types in Payload, and you can run that asynchronously so it doesn't block everything else, but there is overhead there, and it does feel like that's an extra step that you have to remember to run. You can set it up to run when your server starts and all this stuff, but it just is overhead that is unnecessary with inference. It's just an interruption, and there's more lines of code. So when you generate a file, that file exists in your repo. It's just another file you have to worry about, and yeah. I love that DX of Drizzle. I really wish that we could hit that with Payload, and we're gonna work towards it, but it's impressive, frankly. And type generation is pretty expected. It also kind of feels weird to run on a server. Like I had to go to my terminal and boot up Payload to get this even to work, but in Drizzle I didn't have to do anything. And you have to keep types in sync with your other applications as well. So when you publish a change to your API and you have new types, you have to make sure to ship those off to your other applications separately, which is kind of a con. So what would Guilfoyle do? What would any of us do that don't have imposter syndrome like me? Like in Payload, what we did was we went with the generation route, and there were some good side effects from that. We were able to move quickly. We're like the only CMS that provides type generation out there. And I attribute that to keeping it simple and getting it done rather than letting perfection be the enemy of good, right? We got it done and it's there. But in the future, I would love to figure out inference. I don't know if it's ever going to truly be possible for Payload because we have certain API approaches, like our plugins, for example, that can inject collections, that can dynamically adjust your config. And I don't know how TypeScript could ever parse out the amount of like dynamic possibilities there are inside of a Payload config. It just seems like something that likely is not ever going to happen. But I want to figure it out. But for now, like our generated types are very clean. We don't have any compromises. Like sometimes if you're gonna start with type inference in mind, then your API is going to be designed to work within TypeScript's limits. And that means that the developer experience using your product has to compromise to fit the requirements of another technology. And with Payload, we did not compromise at all. Like, we designed our API and the way that you write the payload config, it is exactly how we want it to be. We didn't start with somebody else's requirements and fit our product into it. But the generated types, being able to share them, promotes end-to-end type safety. We reuse our types in Next.js all the time. Our website is open source and it's powered by Payload, and you can see how we share the types. And all of our React components are like insanely strongly typed, and they leverage the types from Payload. And that is huge. And we didn't have to pull in our ORM on the front end because we just had to make sure we had that TypeScript generated file there. Our IDE isn't bogged down. It's pretty simple, and we can figure out how to infer later. But so yeah, Payload, it's been a pretty crazy year for us. We've got some big customers already. I thought it was a joke when some of these customers reached out to us, but it's actually, I'm pretty confident we're onto something. We're in use all over the world, lots of projects already. We're just a seed stage company, but we're gonna be building out the team over the next couple of years, and got a bunch of big features coming out shortly, and it's free and it's open source. It's MIT, so you can give it a shot for free. MongoDB only right now, but we're adding Postgres and SQLite over the next month or so. And so there's gonna be a lot more database flexibility in the future. And GitHub stars are a vanity metric, but investors like them. So give us a GitHub star. And I think that's all I got.
Oh, no, it isn't.
I got a question. So I've always found TRPC fascinating, and I've loved, in the past I've worked with GraphQL, and one of the really things I loved about it was having that type safety end to end from my back end to my front end, and I've been chasing that dream ever since. TRPC seems great, but like you have to be using a Node backend in order to get that. Is this something conceivably that would work? So my backend is in Go, and I'm using Amazon's Aurora database. Like conceivably in the future, would this be something that I could potentially use, or are there limitations?
So Payload is a Node package. So your Payload app will obviously always be written in Node, but if you have other backend services that are written in other languages, to leverage Payload types in TypeScript, you're probably gonna need to be writing TypeScript. I don't know if that works some other way, but yeah. GraphQL is tough for like using TypeScript interfaces. I think the two kind of fight each other. But in the future, what we would do is have like a Payload SDK that actually just uses the REST API rather. And it would basically take those generics or those interfaces that we generate, and then everything would still be typed. So, but your question though, you would have like a Go service somewhere that you would want to hit the Payload API and then have...
I would want to generate my TypeScript types from like my database schema and whatever it's written in Go, and use it in my front end, which is TypeScript.
Oh yeah, you could do that for sure.
Okay.
Yeah,
that's what I want.
Yeah, definitely. You'd still have to have Payload running somewhere for the actual generation,
right,
but it would definitely work for that.
Cool. Thanks.
One thing about Payload is that it is self-hosted, and so you do own your own database. Like, I don't know if anyone's familiar with headless CMSs, like the concept. Most of them are third-party APIs, like SaaS products, where you don't even see your database ever. The only way to get to your data is to go through their APIs. But Payload, like, it's your database. You can do 1,000 things to it if you want, wherever you want. And it's always going to be yours. So if you have another service talking directly to the database, do it. Like, that's all. Good question.
So you're generating the types using like Drizzle as like a builder of those types. Is that correct?
So no, we're not using Drizzle for type generation at all.
Okay, I'm sorry. But so are you like writing? So what ends up being the source of truth for the types that you're generating? Like ultimately,
the payload config.
The config.
So the payload config itself, it's very robust, but it's also very succinct at the same time. This is a very simple config. This only has one collection called people, and it only has 2 fields on it. But this is basically the config that drives everything that Payload does.
So this is also populating your database schemas from this config
Correct.
as well? Okay.
Correct. Like the shape of this, whatever you define here, whatever database you're using, we translate it into the schema for that database. So for example, MongoDB, there is no schema. Like you just save whatever you want. But in like Postgres, for example, you have to manage migrations and DDL and all that stuff. So
That was gonna be my question. Like, how are you handling migrations? But
yeah,
with
so
Mongo,
that's
you're
what we
not.
use Drizzle for.
Okay.
That's the part that Drizzle comes in. We did not leverage Drizzle's type inference because we already had it solved with our generation. But we do leverage Drizzle for migrations specifically and for actually running SQL queries.
So it's actually able to generate the SQL query to run
Yep.
to like add a column or whatever.
Yes.
Oh, nice.
Yep. And we're working on building that right now. It's not done yet, but within the next couple weeks it will be.
This is a perfect example. On line 10, let's say I wanted to change this from first name to 2 columns, one first name and one last name. Or actually, it's first name, last name already. Sorry, go the other way. Yeah, full name. Let's say I wanted to change this to full name. Could you show me, like, talk us through like what that feels like on production to deploy that change?
Yep. So there's 2 kind of ways to look at migrations in general. There's the DDL stuff, like changing the structure of the database. But then there's also the layer that you have to change your data. Like you have to actually manipulate the rows in your database. And a lot of ORMs, it's a good question because a lot of ORMs just simply output SQL queries for you to then run yourself against your database, like alter table, add column, whatever. But you still, most of the time, need to have a way in like TypeScript to massage your data on your own. So like the typical, like in Laravel, it's the up and the down function in the migrate files that they maintain for you. We've got all that built into Payload. So you can create a migration and then you can, not only do you have the SQL to actually make the DDL changes, but you can also manage the data transformation in that same migration. So that's all built into Payload.
How would I make it? How would I change it? Okay, so the question I'm building to is, so I make this change that we just did to full name, and then I realize that, you know, that doesn't work for me or whatever, and I want to roll it back. What does it look like with Payload to make that rollback and change? I just change the data in reverse with the migration.
So every time you remove a field or you remove a collection, we're actually going to prompt you to say, like, this is a destructive change. Do you want to do this? And in dev mode, locally, against a local database, that will show up in your terminal and it will prevent you and then you have to accept it. But in production, it's up to you to run the migrations. So if you did make that change and you applied it to your production database, you need to run another migration after that reverses the change. But we do have the up and the down function. So if something fails when you actually apply the migration, then it will run the down function that will actually reverse the changes for you.
Oh, that's really neat. It does that all on its own.
Yeah.
Oh, okay, cool.
So if I like split full name into 2 columns and I say they're not nullable, like how is it going to transactionally, like if I was writing in SQL, I would like transactionally create the new column and populate it or whatever. But like if you're doing it in TypeScript as well, how the transformation you described, how does that work? Is it an all at once thing or are you like streaming rows to a transformation to like manipulate it?
So if you're changing data, that's going to be up to you to write every time on a transaction basis though. So Payload also comes with transactions, and those up and down functions that I mentioned in the migration files are based on transactions in general. So you would write your own transaction, but it would be up to you to write that. There's no way that we can infer how to do that basically. And also changes like adding not null when there's already a column that is nullable. Those are also not something that we can do for you because you might have columns with null and we don't know how to populate those columns for you. So that would be one of those things that we'll throw a flag and then you have to manually handle that.
Okay, I wanted to mention a different thing. Did you know, or maybe you guys have looked into this, it's actually possible to plug the language, the TypeScript language server. So if on your path, because I feel like that's a middle ground that I don't see a lot of places exploring. In fact, there's a language, basically the only language server plugin that's legit is there is a GraphQL plugin to try to give that drizzle functionality, but it's actually generated code. But the plugin is generating the code in the background and then passing that to you for the language server. It's pretty complex to do it, and I don't think anybody has really quite figured this out yet. I've tried to, certainly haven't gotten there, but I've done some proof of concepts. It'd be cool to see you guys look into that, because then you could get that very real time, like don't need to save your file type of experience, but with a config.
Yes, that's exactly how I would envision us implementing inference in the future. And that's why this is still an open door for us. Like, that's the holy grail, I think. If we can figure that out. I think we also already have everything that we need for that, because all we would really do on the TypeScript side is like a declare module, like a fake one in the background that like overwrites the files for your IDE. And then we feed it in the JSON schema that's up to date with the current config, and TypeScript in the background, the compiler, actually uses some declare module to override the built-in types there. So that's definitely, that's something that we need to look into for sure.
Yeah, because it's so funny how many people are spinning their wheels on the same problem that you're trying to solve.
Totally.
Like this is a space that has had so much blood spilled over it, and I think nobody has quite figured out the right way to do it yet. It seems like it must be a very tough problem to solve. From like a genealogy standpoint, it seems like actually TypeScript in this file in front of us is not the source of truth. The real source of truth seems like it's a JSON schema file. Like that's the common ancestor of all of this stuff that gets created on the front end and the back end is actually this is used to create the JSON schema, but the JSON schema, so like thought experiment, if something was wrong in the JSON schema, then it would be wrong everywhere else, right?
Well, so this is the payload schema right here. So earlier when I said that your schema and your ORM is your source of truth,
yes,
that's this. That is the source of truth here. The JSON equivalent to that, like this is full TypeScript. So I can have like hooks and I can say like after read, and then I can write a function here that like returns, like let's say, okay, I have the value and I want to return the value.to lowercase or whatever. Like I can do that right here, and this is the source of truth. The JSON schema is dynamically generated. There is no storage of that. The source of truth is the payload config.
The reason I'm asking about it is, couldn't you use that JSON schema as the plugin point to anything else, like to Ian's use case that he was talking about? Like, is there a future where you do dump that JSON schema file to disk somewhere so that because obviously so many tools and many languages support JSON schema. I'm just curious if that's something like a place that you could see this going in the future if you wanted to kind of free up more use cases. But I guess I wasn't thinking about, so is there like React stuff you can do in here as well?
Yeah.
Could you show that? That'd be really cool.
So one thing, that change to store the JSON schema to disk would be like 2 lines of code to write. Like we just haven't been asked for it yet, but it does exist and we do have it that we could write to a file. And that's a great way to share that with like, for example, like any type of API documentation, whatever you want to use, like JSON schema is universal, right? You can work in any language, but yeah, that's a great idea. We do that with GraphQL type schema generation already. We can write that to a file, and we also write the types to a file, but the JSON schema, that makes sense.
Show the React stuff though. I want to see that real quick.
Well, before that. So I was just going to say that like you don't need to use the JSON schema as a source of truth. You can use the database too. Like for us, we generate our code with SQL Boiler for Go, just from the database itself. So if you're using this to create the database, you can use the database to create like schemas for whatever language you want. Because that, for you, that ends up being we're mixing around source of truth. That ends up being the real source of truth is the database.
Well, the problem with that is when you get into like many-to-one and one-to-many and these different types of relationships, like you kind of want a little bit tighter TypeScript safety than what the introspection can provide to you. Like introspection will give you like literally here's your columns and here's like each table is represented in columns. But like Payload's interface generation goes a couple steps beyond that to like actually how you're going to use the data from the Payload API.
Wow,
So
that was such a great takedown. Take that, Aaron. That's exactly that's what I was thinking, but you said it way more eloquently than I could have. That like, yeah, it's like it's like looking with like 2D glasses at a 5-dimensional world. You know, it's like, well, I guess there's 2D glasses don't really exist.
well, like
YouTube, I will not edit Aaron being wrong.
yeah, I mean, we are an abstraction over an ORM. So like you do get a lot of things in Payload that you don't get in an ORM. So like that's where that comes in. Like Drizzle actually does use introspection to pull their equivalent schema out of the database and generate your schema file for you. So if you had a crazy Postgres database, in Drizzle you can literally run introspect and it will build you a schema that represents your database. But that's literally a shot-for-shot recreation of your columns. So Payload has a little bit more stuff than that. Should we do React?
React, yeah, let's do it.
All right. So React is super cool in Payload. You can customize just about every single component in the admin panel. And it's really easy. All you do is, well, let me show my sidebar here and let me make a new file called mycustomfield.tsx. Import React from React, export const my component. I need to close this tab for a minute. There we go. Return. Let's say hello, Michigan. Okay, so very simple React component. If I wanted to render my own field for this full name component, first I'm just going to show you how this renders in the browser, and then I'll show you how easy it is to render a React component in place of it. So this is still running in the background. But if I go over to my browser somewhere, and I need to create a user, and I go to people, create one. Here's the full name field. It's just a text input, very simple. We have like 22 field types, so like all kinds of crazy stuff, like tabs and like layout builders and arrays and geolocation fields. Like we have all kinds of different fields, but this is like the simplest one, right? But if I wanted to swap that React component out, that full name field, all I would have to do is import it. Components, field, my component, save it. And I should have organized my, there you go. So there it is right there.
Wow.
And you can do that with entire views. You can do that with the sidebar. You can inject your own navigation components. You can literally do whatever you want. And we have hooks to interact with the form as well. So we have a bunch of hooks to interact with the form state. And one common use case, like you have a select field, right? Like an enum in your database or whatever. But you need to populate that dropdown with records from Salesforce or some other API or whatever. Like you need to reference something else in some other API. So you got to dynamically fetch your options and then render it into your select. In Payload, that's really easy. You can import our built-in select component, go fetch your options, and then manage the form interactions yourself by set value and all that stuff. But it's all built for this type of customization. It's all very, very like native to Payload.
It's so cool too that before you did this, it said full name. Maybe it's not cool to you, but it's cool to me. It said full name and it had the field there, which is what we changed on the fly while we're standing here.
Yep.
That's really, really neat. Okay, I have my last question, I promise. If I'm migrating my company's, you pick the easiest case, I guess, or the hardest, whichever you think. But if I'm migrating to Payload, what does that look like? Like, how do I get all of my data? I haven't written your custom config. I, may have some bits and pieces, but like, what's the migration path to your company look like?
So I kind of mentioned earlier about how the data that we save in the database is exactly how you define it. Like a lot of, especially in the CMS world, like there's the CMS way of doing things. And you have to learn how to use that CMS, and their data structure is crazy. And like there's 35 tables. Back to WordPress for a minute. I'm sorry for talking about this because it gives me hives, but like there's a WP posts table, and that has title and content. And then everything else that you save on a post goes into WP post meta. And then it's a key value pair for every single other field. Like if any of you have ever had to deal with that, that is a very WordPress specific database design, right? That is not the shape of your data. But in Payload, literally it saves exactly what you tell it to save. So if you had a database, you don't even need to change it. All you have to do is just recreate your schema in the Payload config way, and then it's good. And then pass your connection string. So it like pretty much the Payload fields allow you to like meet any type of existing data that you have. In the relational world, that's going to get a little bit harder because that's one place where we have made optimizations. For example, like a big project for Payload could be like this Hope Network website where like this is built on Payload, and this is a page in React or in Next.js. But this page has, the home page has 45 links to other pages that are dynamic, right? They're relations that all need to be dynamically populated when you fetch the home page. When you get the home page, you also need the JSON for all of those linked pages so that you can build up the links and everything like that, right? And so that's like pretty specific. Let me see. Like this is the type of data that gets saved in payload, and it's exactly what you would expect. But in the relational world, we did make some performance optimizations. So it's going to be easier to bring a MongoDB database than it is to bring an existing Postgres database.
James, thanks for coming out and talking to us.
Of course.
I'm a little confused. I really like the type generation stuff. Is this something you would be expecting a typical user to be concerned with? Is this like a payload admin would be looking at this, or is this more a behind the scenes thing?
Well, the end users of payload, I mean, we kind of target engineers first and foremost. There will be a day where we try to widen our appeal, but right now we're concentrated on developer experience. So like if you're writing custom endpoints in your node server that you already maintain, or serverless function, whatever you're doing, like you should have the best developer experience possible. So that's why we're really concentrating on the type generation in specific, so that you can build fast and confidently. And that doesn't have any ramifications to marketing people at all. They don't care. Like business admins, they don't care at all, but you do. And so that's why we're placing so much emphasis on this. It's just an internal thing for developers. Is that like what you were asking?
Yeah, like I guess part of my background comes from like e-commerce with Magento or something like similar to the WordPress side. And like, you know, if you're writing your own plugins or something, then you care about like the structure of those tables and whatnot. But you don't necessarily need to be writing code at all to be getting value from the platform. So yeah, it sounds like you are expecting people to customize the platform, or at least providing that option and encouraging people to do it.
They do a lot right now.
Cool.
Like I was kind of illustrating earlier, we're not only for brochure websites. There are massive SaaS applications already built with Payload. One of them is Payload Cloud. Literally, our cloud platform is built with Payload on the back end. And that has a jobs queue, that has like a Stripe integration, that has subscriptions, that has very robust access control for who can do what to the API. Like there's just a lot of very nitty gritty back-end type things that we built out. And we just like having those types at our disposal made the entire thing much more doable for us. There's also like a full broadcast platform built on Payload already that like literally it's like a video streaming service. You can sign up for your own Roku channel, but all of it, like if you're gonna make a Roku channel, you gotta log into an admin panel and you gotta upload the video and you gotta choose your cover photo and write the meta description, and that's just content, right? But that's not website content. That's like an application's content. It's almost like the back office for a SaaS app. So we see that a lot. And that's only scratching the surface. People are doing crazy stuff. There's a casino built with Payload, and they have millions of records in the database, and it's pretty wild. They showed that to us, I think, yesterday? I don't know what day it is. But yeah, when you build that kind of stuff, that's where it comes in.
Awesome.
Here we go.
Oh, there it goes.
We're back.
All right. We'll just have to pretend that didn't happen, huh?
It's part of it.
Fix it in post.
Yep.
Definitely will.
The only problem is that I don't remember where I stopped, so.
Who remembers where he stopped?
Just start over. Like,
Oh, from the beginning? Yeah.
you need to